Okay, on we go with task 3. Busy day making all of these. One more to go. So this one's quite concise, not that much to it. Correlations and types of data. So you need to know what correlations are. Need to be able to describe them. Different types of correlation. Need to know that they're not experiments. That's important. And then we'll move on to quantitative, qualitative data, which I'm sure you're comfortable with, and primary, secondary data, which also you're probably comfortable with from other subjects. So, correlations. Please get into your heads that these aren't experiments. It's so important that you see the difference. Experiments look at differences. Experiments have an independent variable. It has conditions. You have the DV. You don't have any of that with correlations. You're just looking at a relationship between what we call two covariables. The other thing to bear in mind, we'll come to this in a bit, correlation does not equal causation. Right, so if you look at these graphs here, positive correlation, as one variable increases, so does the other. Hopefully, hours spent revising and exam marks in exams would be an example of that. Negative correlation, as one increases, the other decreases. And then also you've got something just there's no correlation at all. Now, a correlation coefficient, don't be put off by the word in here. All it is a statistical way of showing what you just looked at on those graphs. It's a statistical way of showing the strength of a correlation and also the nature of it, i.e. is it positive or negative. Now, this is on a range from -1 through 0 up to +1. +1 would be a perfect positive correlation. Hold on, I'm back to funny, I can't do that. As one goes up, the other goes up. Yeah, -1 would be a perfect negative correlation. Not often you see that, to be honest. The closer the figure is to 1, be that +1 or -1, the stronger the correlation. The closer the figure is to 0, the weaker the correlation. So I've nicked this little graph here that I found online. Hopefully you can see what I mean. So in the middle you've got 0 with no correlation whatsoever. As you go towards the left, you're getting an increasingly stronger negative correlation. If you go to the right, you're getting an increasingly strong positive correlation. So exactly what we saw in those scatter graphs before, but in a statistical form. So don't be put off if you're asked by what is a correlation coefficient. A statistical way of showing the strength and relationship, and nature of the relationship between two variables. So we've seen them already. I tend to call them scatter graphs, scattergrams, same thing. These are the graphs that you use to present correlation. So you plot on the one variable on the x-axis, the other on the y, and you put those two scores together to put your point. You keep doing that, and then you look at the nature of the pattern. You can do your line of best fit. You'd be looking at a pretty strong positive correlation here. Now, this is my usual go-to example, number of drownings and ice creams sold. Is it that people are so heavy from eating so much ice cream that they drown? No. So we'll come back to that example later on. So you need to be able to evaluate the use of correlational analysis as a research tool. It's a good starting point. That's one of the strengths. It's good for preliminary research. So before you invest too much in your research, you can do some preliminary research. If there's no correlation at all, then that suggests it doesn't warrant further investigation. But if you do establish a strong relationship, no, at that point you can't talk about cause and effect, but it might warrant going on to do experiments that then would allow you to do that. But it's worth doing the correlation study first to tell you if it's worth doing that further research with all of the time, money involved in that. Also, if you can't experimentally manipulate things because it'd be unethical, if a correlational study can be done if it's happening anyway, then that's another option there. And yes, it does give you access to data in the public domain, so you can quite easily find data and do a correlational study there. Now, the absolutely crucial thing that's bound to come up if they mention correlations is cause and effect. It does not establish cause and effect, no matter how strong, even if you've got a perfect +1 positive correlation. it doesn't mean that one has caused the other. So going back to the ice cream and drownings example, no, increased ice cream doesn't lead to increased drownings. It hasn't caused it. It's the hot weather. The hot weather leads to more people buying ice cream. The hot weather leads to more people going in the sea and drowning. Okay, so that's what we're getting at. So never ever, when you see a correlation, do you talk about cause and effect. There may well be something else going on there. That's the key thing. So if nothing else, have that in mind if you're talking correlations. Also, it is only linear relationships. So it's a positive correlation, negative correlation, no correlation. There are some relationships which are a bit more complicated than that, and they increase as positive to a certain point, and then they may decrease from there. Curvilinear, that's called. So that's another thing just to bear in mind. I think in the book it gives the example of temperature and aggression. This is on the old spec we used to do that. Yes, you've got a positive correlation. The hotter it is, the more aggression you'll see. Actually, it gets to the point where it's so hot you can't bother to do anything. So then it'll tail off. So it doesn't give you the opportunity to show that in a correlational study. And then for the second part of this, types of data. Again, I'm not going to hang around on this. We've done this a lot. Quantitative data, numerical data, qualitative data, non-numerical. The main risk is, to be honest, people rush and just read it incorrectly. It's so frustrating. They know what it is, but in an exam, yes, they look vaguely similar. So please take your time. It's very frustrating when people drop marks on this. So numerical data, what's the strength of one is the limitation of the other. As I keep saying, that happens throughout research methods. So quantitative, very easy to do your statistical analysis, descriptive statistics, averages, whatever you want to calculate. Inferential statistics, which is what we'll look at next year, where you're looking at whether it's actually statistically significant or not. You can do that relatively easily with quantitative data, but the trade-off is that it can be quite superficial. Going back to the questionnaires, I gave examples of scales. If the average enjoyment score for psychology is 7.4, well, great, but that offers me a very limited insight. So might not actually have that much validity, to be honest. It's just people putting a rather artificial score out of 10 on a piece of paper. Whereas qualitative data, non-numerical language-based data, so words, sentences, has that rich detail. And if I've got lots of data where students have written a paragraph on how they feel about psychology, that gives me a much greater insight into what they're doing. So probably more valid than a score of 7.2 or whatever I said. Okay, so that's the trade-off there, but it is much more difficult to analyze. Not impossible, but a lot more difficult to analyze qualitative data. Okay, and much more difficult to draw your conclusions, do your comparisons compared to quantitative data. And then primary data, as opposed to secondary data. Primary data ultimately is data that's being collected specifically for the purposes of the study that you're doing. So the researcher is collecting the data for the study that they are carrying out. The participants are reporting directly to that researcher. The good thing with this, the data it's being collected in a way that's designed for your particular study, so you know that it's going to give you what you need. You know that it's being collected in a sort of valid way, and the nature of how it's being collected, you know it's fit for purpose for your study. But you've got to do all of this. You've got to get your participants, you've got to do all of that. So time, effort, money. As always, that's something to bear in mind throughout research methods. It is a factor, an important factor. So if you're not going to do that, you might use secondary data, which is data that already exists. It's been previously collected by other researchers for other purposes. Okay, and you're just using this for your own study. So hopefully you can see the difference between the two there. And once again, we've got the reverse pros and cons here. So it requires less time, effort and money and time because it's already there, it already exists. So all that, getting the sample and collecting it, and all that's gone. It's already there. Fantastic. But you haven't got the control over it. So the nature of how it was collected and the validity of the data might be more questionable. and ultimately could then hinder the validity of your study. Okay, so if you're collecting the data directly for your study, you're in control of how that's being done. If you're relying on data that's been collected by other people, then that opens the door to these kind of issues. Okay, so it's a trade-off between the two. And I think this is the last thing, meta-analysis. We've talked about meta-analysis before. Sometimes you say a study of studies. It's where you're not collecting new data. You're just pulling together, you're drawing together findings from different studies on the same topic to try to establish overall trends, to try and draw some overall conclusions. So particularly useful when it seems as if there's mixed findings in an area. Okay, well, rather than just one study, bring them all together. What do they show? Now, the good thing with doing this is you end up with a much bigger sample size, because rather than just the sample for one study, you might have the sample from 20 studies. So you're going to have a large sample, which should make it easier to generalize. You should have greater confidence in generalizing the findings from that. Whereas with one study, there could be various issues when it comes to being able to generalize, be it the type of person used, the culture in which it was conducted. But it does come with the risk of researcher bias, and they're going to be making decisions about which studies are going to be included. So that does mean that studies could be not included, that maybe should be, particularly if they haven't got positive findings, if they didn't find a relationship or an effect, then they might not be included when actually that might still be important. So that's a risk with this as well. Okay, and obviously I haven't got it here, but it can be. I think you would probably have talked about this. An example is the one in attachment and cultural variations. Studies can be quite different in the way they're done and collected, so you're not always really putting together like for like, which can be an issue as well. Okay, I think that's it.